7.3, proving triangles similar. Okay, so they're telling us that angle A is congruent to angle R, angle B is congruent to angle S, and we need to see if triangle ABC is similar to triangle RST. Okay, so we want to find our scale factor. And to find our scale factor, which we will name K, we're going to take side RS and divide it by AB to show that those two sides are similar. Okay, that will give us our scale factor. Okay, so then to create our AB prime, our dilation of triangle ABC, we want to multiply AB by our scale factor. Okay, so I'm going to plug in that scale factor. So AB prime equals, our scale factor is RS over AB times the AB. Well, AB is canceled out by that. So we are left with AB prime equals RS. So we are able to prove that our dilation of AB, which ends up giving us AB prime, is equal to side RS of our similar triangle. Okay, and then to write our statement, we would have a dilation with a scale factor of K, and we would be dilating about A, and that's going to map triangle ABC to triangle ABC prime, and then our triangle ABC prime is similar to triangle RST. Okay, our triad. If angle A is congruent to angle R and angle C is congruent to angle T, how can we prove that our triangles are similar? Okay, so this image was wrong, so we're going to ignore this information right here. So we know that angle A is congruent to angle R and angle C is congruent to angle T. We want to figure out how to prove that our triangles are similar. So very similar to the last example that we just did, example 1. We're going to find our scale factor. So K is going to equal those two sides divided. So RT over AC. All right, and then we can prove that our dilation will equal the new image. So A prime C prime would equal our scale factor times AC. So RT over AC. Those will cancel out, and we're left with that A prime equals, or A prime C prime equals RT. So then to create our similarities, dilation of the scale factor of K about angle A will map triangle this time it is ACB because they gave us angles A and C. To triangle A prime, C prime, B prime, and that triangle A prime, C prime, B prime is congruent to triangle RTS. We're able to prove that by angle, side angle. So angle ACB is similar to angle RTS. Okay. Next, our angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if we can prove, or we know that two angles of one triangle are congruent to two angles of another triangle, we're able to prove that the triangles are congruent. Okay, example 2. If LM over PQ is equal to MN over QR is equal to LN over PR, is there a similarity transformation that maps triangle PQR to triangle LMN? And we need to explain. Okay, so first our scale factor is just our sides divided. So LM over PQ would equal MN over QR would equal LN over PR. Okay, so that is our scale factors. And we're going to use whichever of those scale factors helps us prove that our original image is similar to a dilated image. Okay, so let's start with side PR. So I'm going to have PR prime is equal to K times PR. I'm going to plug in my K. And when I plug in my K, I want to plug in my K that has a PR. So I would be plugging in this for K. So LN over PR times PR. So that's going to cancel out the PR. So PR prime would equal LN. Okay, next one, PQ. P prime Q prime would equal K times PQ. Well, for this one, I want to plug in the one with PQ in it. So LM over PQ times PQ. Those cancel out, so PQ, or P prime Q prime, will equal LM. And then finally, QR, Q prime R prime, so this one would be MN over QR. That cancels out. So Q prime R prime equals MN. Okay, so because our sides are congruent, so PR and LN, PQ and LM, and QR and MN are congruent. Okay, so because we have three sides that are congruent, we are able to prove that triangle P prime Q prime R prime is congruent to triangle LMN by side, side, side. So that means that triangle PQR is able to map, so it was mapped onto triangle LMN. And it was mapped onto LMN by similarity transformation. Let's look at our try it. Okay, so if DF over GJ equals EF over HJ, so they're telling us that those ratios are equal to each other, and that angle F is congruent to angle J, is there a similarity transformation that maps triangle PQR onto triangle JM or LMJ or LMN? So we want to start by proving that our dilations would be equal. So G prime J prime would have to equal our scale factor times GJ. Well, our scale factor is DF over GJ. And that would cancel out, so GJ equals DF. Do the same thing for HJ. So H prime J prime, K times HJ. This one I'm going to use EF over HJ. So HJ prime does equal EF. Okay, so GJ, DF, HJ, EF. Okay, so we have those similarities and congruences. So we are able, by side angle side, to prove that triangle DEF, and I just noticed that these are wrong, so this should be DEF and GHJ. So triangle DEF is congruent, D prime, E prime, F prime, is congruent to triangle GHJ. Okay, so we are able to prove that triangle DEF will map onto triangle GHJ. Okay, next we're going to look at side-side-side similarity theorem. All right, so side-side-side similarity theorem tells us that if the corresponding sides of two triangles are proportional, then the triangles are similar. So if we know that we have all three sets of corresponding sides, then we know that our two triangles are similar to each other. All right, next is the side angle side similarity theorem. So if we have an angle of one triangle that is congruent to an angle of the second triangle, and the sides that include the two angles are proportional, so that means that the sides that are adjacent to that angle are proportional, then our triangles are similar. So if we know that angle A or angle B and E are congruent, and we know that A, B, and DE are similar, and BC is similar to EF. So if we have a side, an angle, and a side, then we are able to prove that our two triangles are congruent or similar. All right, example 3. Are triangle ABC and triangle DEF similar? And they gave us some measures here. So we want to prove that the sides are similar. So we're going to create our scale factors. So my first side, AB, should be similar to DE. Well, AB is 3, DE is 4.5, so 3 over 4.5. When I reduce that down, I get 2/3. Our next side would be BC, should be similar to EF. So that'd be 4 over 6, which will again reduce to 2/3. And then finally, side AC and DF. So 5 over 7.5, which will reduce to 2/3. So because all of our scale factors were the same, we can prove that our two triangles are similar through side, side, side. Okay, so we're able to prove it through side, side, side similarity. All right, try it. Is triangle ADE similar to ABD? Explain. So ADE, we're looking at this triangle right here, and we're trying to see if it is similar to ABD, to this triangle. Okay, so we want to see if those two triangles are similar. So I'm going to see if my sides are similar. So AE. And the easiest way to match these up is the order in the triangles. So AE would match with AD. AE is 1.8. AD is 2.4. That's going to reduce down to 3/4. Change my color. Next, let's do DE. So DE would match with BD. So DE is 1.8. BD is 2.4. Right, and then for good measure, we will do our third side, so AD and AB. AD is 2.4. AB is 3.2, which again would give us 3/4. Okay, so all of my scale factors are the same. So we are able to prove that triangle, that's a weird triangle, triangle ADE is similar to triangle ABD. We're able to prove that by side, side, side similarity. Okay. B is ADE similar to BDC? Let's come back up here. Let me erase. Okay, so we're looking at ADE, DE, and BDC. So we're looking at, BDC. Okay, we're looking at those two triangles to see if they are similar. Again, I will match them up by the triangles. So AD and BD. So AD is 2.4. BD is 2.4. That would get me 1. Next, I will do DE and DC. So DE is 1.8. DC is 1.4. I can tell those aren't going to get me 1. I'd end up with 9/7. So those two are not similar. I don't even need to check the third set of sides to see if they are similar, but I'll go ahead and do it just to make sure we've covered our bases on how to find that third side. So our third side would be A and E with BC. Okay, so side AE is 1.8. BC, oh, well, they didn't even give it to me, so I can't do that. Never mind. Okay, so we cannot prove that those triangles are similar. Okay, and we are not able to prove it because AD over BD does not equal DE over DC. Oh, I missed. Okay, let's go back over here to B. Missed that one. All right, B. Are triangle PQS and RQP similar? Okay, so let's set this up. SQ or QS, we'll do SQ. SQ would match with PQ. So SQ is the 13 and the 12 together. So 13 plus 12, I'd get 27 for SQ. PQ is 18. 27 divided by 18, I'm left with 3/2. Next, I will do PQ and RQ. PQ is 18. RQ is 12. And those do give me 3/2. Okay, so those two ratios are the same, so we are able to show that triangle PQS is similar to triangle RQP by side angle side. Okay, and the angle that is similar is Q because they share that same angle. So we have two sides and that angle Q that are similar. All right, example 4. What is MN? Okay, so we know that angle JLK would be similar to MLN through vertical angles. All right, we also then would be able to prove that triangle JLK is similar to triangle MLN by side angle side similarity. Then we can set up our scale factors. So MN would go over JK. And ML would go over JL. Plug in the information that I know. We don't know what MN is, so I'm going to leave that as MN. JK we know is 10. ML we know is 1. JL is 75. Okay, I'm going to cross multiply to get me 75 MN equals 10. Divide both sides by 75. So MN will end up equaling 2/15 once we reduce it. All right, our try it. If the measure of JL were 150 instead of the 75, how would the value of MN be different? Okay, so now they're telling us instead of this 75, it is 150. How is the value of MN different? So we would just take what we set up over here and replace the 75 with 150. So we'd have the MN over 10 equals 1, and instead of the 75 we would have 150. Would cross multiply. So MN is going to end up equaling 1/15. Right, B, if the measure of JK were 20 instead of 10, how would the value of MN be different? Okay, so this time JK, instead of this being 10, it is now 20. And we're going back and our JL is now 75 again. Okay, so I'm going to come back over here and set this all up. So MN over the 20 this time instead of 10 would equal 1/75. Cross multiply. So MN will end up equaling 4/15. All right, example 5. Avery puts up a radio antenna in his yard. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the lengths of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it? Okay, so we want to set up our ratios here. We're trying to find the height of the tower, ST, and that should match up with BC. We know RT, which would match with AC. Now I can just plug in the information. So ST we don't know, we're going to leave that as ST over BC, which is 6. RT is 40. AC is 5. And we'll cross multiply. So ST ends up equaling 48. So that means that the tower is 48 feet tall. Which is below the limit of 50 feet. So his tower is okay. All right, if the tower were 50 foot tall, how long would the shadow of the tower be? Okay, so now they're telling us that our tower is 50 foot, but we don't know how tall or how long the shadow is, so we don't know the RT. So then to set this up, it's very similar. So we'd set it up as ST over BC equals RT over AC. The ST this time we know, because they told us the tower this time is 50 foot tall. Our BC is still 6. The RT is what we don't know. And our AC is still 5. Cross multiply again. Okay, so once I simplify that, this shadow is 41.6 feet.